Welcome, grade 11s, to the ambiguous case. What do you think? It's too much. It's too much. Okay. Well, it was a bit of fun. So here we go. Let's look at this. That's our beloved ambiguous case. So here we are. Let's give you half a chance to draw that triangle down. And, this time I won't go pause. I'll just go, jot down the triangle. There it is. So, yeah. So the ambiguous case. Let's see when this happens. So I'm going to give you this triangle. By now you've drawn it, or maybe you haven't got yet, but jot it down and let's see. So over here we've got our triangle. I'm dancing around here. And we've got an angle over here. And we've got a side opposite it. Cool. And we've got, a side over here and an angle opposite. And for the last part, well, we've got this side over here and this angle opposite that we don't seem to know much about. So, gung ho we go, well, let's find out what Q is first, right? Because we don't know that angle, but we know the side opposite it, and we know another side angle pair. So we write down what I mean, and then I'll give you a chance to catch that up to go, well, we don't know what Q is, so let's go sine of Q over 91. And that's going to equal, well, now we've got the yellow pair, right? So we're going to go sine of 49,5 degrees over 73. So let's just take a pause at that moment and take that in. Okay, so we've kind of paused and seen that and gone, okay, that's great. We've got something now and we can find out what Q is. So to each side of our equation, if we multiply this by 91 and we multiply this side by 91, we'll get that the sine of Q is, and we pull this thing up, right, our calculator, and go, okay, so sine of Q, well, what do you get? And let's see if we get the same thing. So let's have a look here. We've got this fraction sine of 49,5 close bracket divided by 73, and if we multiplied that by 91, cool, 0,947 dot, and therefore if we want to find out what Q is, well, we just did arc sine or the shift sign of that of 0,947 and I don't know what that was either. And everything's in the way today. So let's do this and go, okay, so we want to go shift sign of that answer, 71, I'm just going to go 71 degrees. Let's go to no decimal places. And let me just double check my rounding off. Does that seem right? Okay, so 71 degrees. Cool, so we go, that's 71. And we merrily find this angle P and this side P. Okay, so let's go for it. What is the angle P over here? This one here. So P equals what, and how did you get it? Okay, well, I reckon just sum of angles in a triangle. So P is, we're going to go 180 minus this 49,5 degrees minus our 71 degrees. And we should get, I don't know, whatever we get, right? Calculator to the rescue and says, well, 180 minus 49,5 minus 71 equals 59.5. Cool. And then we could find P. Well, let's go for it. How are you going to find out what the value? So let's actually just put this in before I finish that question. Degrees. How are you going to find out what our side length P is? Well, we'll just do that kind of sine rule thing again. So P over sine 59,5, and you'd know that I'm probably going to use this yellow combination because we're given it. So we've got 73 over sine 49,5, and so we just multiply by sine 59, whatever, and we get P. So calculator, where was it? Here. It shouldn't, do you know this one, right? It shouldn't be called a calculator. What should it be called? Is it calcu now? Okay, maybe you got that already. Okay, so we've got we got 73 over sine. Where is it? 49, comma 5. Oh no, where are we? And we times it by sine 59, comma 5. Right? We just multiplied both sides of our equation over here, times by that denominator, times by the denominator. And we get 82,7, what? Let's call it 83, right? Keep our lives easy. 83, I don't know what I put on. So that's 83, and there's our triangle. Okay, it seems to make sense. Biggest angle is over here, the red one, so the side opposite. The biggest angle should be the biggest side. The smallest angle is here, so the smallest side is opposite the smallest angle. Just little bits that remember. Okay, so that's all well and good, except I want to draw the triangle like that. So just write down what you think at the moment. So if we draw there's the triangle. If we draw the triangle like this, notice this angle Q over here. What's different about angle Q? And how do you think we're going to find out what angle Q is? Okay, well, one major difference is it seems like a really big one now, right? An obtuse angle. It's bigger than 90. So that bit still goes with that bit. You know, we've got this angle here still goes with this, and the third one, which we're not worried about at the moment. So still, if we want to find Q, our first steps would be the same. Sine of Q, not theta, sine of Q is, well, if we divide that by 91, it'll be equal to sine of 49,5 over 73. And I'm pausing because I'm thinking, but wait a second, we just did this. Isn't this the same? Well, okay, let's multiply by 91, multiply by 91. So we've got sine Q equals, well, we did this already. So what do we get? Sine Q 0,947 what? 0,947 ... Now I'm going to stick in an extra bit and say, let's call this our reference angle is now going to be what we found there before, 71 degrees. Okay, now think back to this beloved cast diagram that we use so much, CAST. In which other quadrant is sine positive? Well, it could be in the second quadrant, right? We could be over here. So we could have an angle, an obtuse angle. So couldn't Q also be 180 minus 71? What is 180 minus 71? Well, I think it's 109. Does that seem close enough? Close enough. Okay, these are all in degrees. So 109 degrees. So let's just check. If that's 109 degrees, could our triangle still make sense? Well, yeah, 49.5, 109. Let's find out what our last angle is. So, sorry, let's stop whizzing around. So our last angle up here, P. So the angle P, how are we going to find P again? Oh, well, just angles in a triangle. 180 minus 49,5 minus 109. Let's just check. What do you get? Well, 180 minus 49.5 minus 109. Okay, 21.5. Okay, 21.5. 21.5 seems to be reasonable, seems to be a triangle. Look, there, it makes sense. The angle still add up to 180. Now, which side is now our shortest side in the triangle? Well, now our shortest side, I'm in the way there, that 21.5, but you see it there. The shortest side now is P. So previously, our shortest side was this side here, R, was 73, smallest angle, smallest side. Whereas in this triangle here, we've got smallest angle, smallest side. So now when we work out P is going to be different. You can see it looks a bit shorter in my diagram, even if it's not perfectly to scale. So now we can say P over sine 21.5 equals, that was exciting, equals, and we're going to go sine 49,5 and 73. So just, not degrees, take a pause there. Okay, so to work out P, we're just using our sine rule. We got the P over the sine of that one is 73 over the sine of that thing, multiplied by sine 21,5 to give us what P is. Definitely calculator. If you don't have one, you can see, you can download this one, either pay for it or get the freebie trial to start with, or just use some sort of search engine to find one. There's some free ones on the web. And we've got 73 over sine 49,5. And we're going to multiply that by sine 21,5. 35, something or other. 35. Yeah, that seems to kind of fit in with the diagram. If we move that out the way and move me out the way as well. So this diagram kind of makes sense now. So it was ambiguous case, because we didn't know whether this was going to be an obtuse angle like in this picture, or if it was going to be an acute angle like in this picture. So, you might be given the triangle and therefore be told it's acute or obtuse. Otherwise, we might not know. So the way that we know is, when is it ambiguous? Well, let's look at this question. So no triangle. This is an ambiguous case. Draw your triangle and maybe just take a guess at how do you think you're going to know that it's an ambiguous case. Well, let's draw it and see. So we got PQR. So I'm going to draw like this. I'm going to draw it like this, almost like it's an equilateral triangle, because all we're interested in is if we've got R over here, and this is 49,5 degrees, and the side opposite is 73, and we're given Q, doesn't matter where Q is, let's put Q over here, and the side opposite that is 91, and that's all we're given, right? An angle, the opposite side, and another side. Well, that's it. I guess we should guess that the other one's going to be P and P or something like that. So if you're given an angle and the side opposite it is the smaller side, then it will be an ambiguous case. So you're given an angle and two sides, and the angle is not included in the two sides, but the side opposite is the smaller of the two. So if you are given angle side, and the opposite side is shorter, oh, I'm in the way of what's going on here. If you are given where's it here? If you are given angle side, and the opposite side is shorter, that's when you have the ambiguous case. So that's when it happens, because you might not be told, hey, this is an ambiguous case. But there, the opposite side was the shorter of the two. The opposite side was 73 and 91 was the shorter. So that's when it was shorter. Previously, we didn't have that. Here we had, we're given two angles on that side. So we weren't told kind of the smaller of the two. And here we're told, we didn't have that. That was bigger. You see, two sides and an angle. And this side, 11, was bigger, so it was not an ambiguous case. Okay, so that's the ambiguous case. Enjoy. I think, of course, you do. Well, where was our music when we finished off? It was really good. Very good. Need some headphones or something like that. Near the microphone.